example 4, we have the quantity of x plus 1 divided by x minus 5 equal to the quantity of x plus 2 divided by x minus 4. So looking at each denominator, I can see that they are different from each other and each is completely factored. So our lowest common denominator is the product of those two unique factors. To find the restriction, you're going to set each of those factors equal to 0 and solve. So when x minus 5 equals 0, adding 5 to both sides will give us an x value of 5. So right away I need to eliminate 5. X minus 4 set to 0 means I'm adding 4 to both sides. So that x value would be 4. So I also need to eliminate positive 4. So the domain is the set of x such that x is a real number, but x cannot equal 5 or 4. To solve the equation, I'm going to take the lowest common denominator and multiply each term in the equation. Can you already see what's going to happen here? I'm going to have that quantity of x minus 5 reducing. On the right side of the equation, starting with my LCD and multiplying by quantity x plus 2 divided by quantity x minus 4, I can see that that quantity x minus 4 is reducing here. So again, I've got some binomials that I'll need to distribute to multiply, and that gives me x squared plus x, then distribute negative 4 to get minus 4x minus 4. On the right-hand side, I also have two binomials, so I'll use distributing x times x and x times 2. That's x squared plus 2x. And finally, distribute negative 5. Minus 5 times x is minus 5x. Minus 5 times 2 is minus 10. Now I can see I have x squared on each side of this equation. So I'm going to collect everything on the left side. I'll subtract x squared. What happens here? It actually eliminates. So at first glance it looked like we were going to have something quadratic and needing factoring, but in fact it eliminated. So we're going to have something linear remaining. To collect my terms, it looks like I have minus 3x minus 4 is equal to minus 3x minus 10. So I'll collect all my variables on the left by adding 3x to each side of the equation. So I eliminate x's, actually on both sides, and I end up with negative 4 equals negative 10. Now we know that negative 4 is not equal to negative 10. So that must mean there's no solution for this equation. So what are restrictions? If we had ended up with 5 or 4, we would have eliminated. But because we completely eliminated the variable from the equation, that's another way to end up with no solution at all. For example 5, we have x minus 2 over x minus 6, and we're subtracting 4 divided by x, and that equals 24 divided by x squared minus 6x. So I'm going to look at each denominator. This quantity of x minus 6 is factored. Here's a factor of x all by itself, so that's factored. But this last denominator looks like there's at least a greatest common factor of x, and that would leave quantity of x minus 6. So our lowest common denominator, we have a quantity of x minus 6. We have an x as a single factor. And then notice that the last term has the same factors, x and quantity x minus 6. X is raised to the power of 1, so we already have enough. And quantity x minus 6 is also raised to the power of 1. So there's our lowest common denominator. Setting each factor equal to 0 will help us to determine any restrictions. So x equal to 0, that already solved itself. So 0 would be eliminated. And to solve x minus 6 equals 0, we add 6 to both sides. So 6 would also be a restriction. So our domain is the set of x such that x is a real number and x cannot equal 0 or 6. So we're going to go back and start with our lowest common denominator and multiply every term in the equation by the LCD. And the whole purpose for that is to make the fractions eliminate. Now I have subtraction, so I'm making sure to use a bracket just in case I end up with several terms inside of that bracket. And our LCD again is multiplied by our last term. And I'm using the factored form. That just makes it easier to see what can be reduced. So back to the first term, quantity of x minus 6 reduces and no fraction remains. In our bracket, it looks like just the x is reducing, but again, no fraction remains. And finally, both factor of x and quantity x minus 6 are reducing. Now I'll distribute x times each term in the quantity, and I'll get x squared minus 2x. In the bracket, I need to distribute 4 to each term in this quantity, and that leaves 4x minus 24. But remember, we have this negative outside of the bracket, so we need to distribute the negative now to each term that still remains in that bracket. Negative times 4x would be minus 4x. Negative times negative 24 would be plus 24. And on the right side, everything eliminated except 24. So our equation is equal to 24. Now to collect our like terms, since it is quadratic, I want to subtract this 24 from each side. So I now have x squared. There's some like terms, that's minus 6x. 24 minus 24 is eliminated, and it's also equal to 0 on the right-hand side. So I have x squared minus 6x remaining. That's only 2 terms, so I can use some greatest common factor. I can see also x is the common factor, leaving x minus 6, set equal to 0. Take each factor now and set it equal to 0. So when I solve, this is already solved. And x minus 6 means I'm adding 6 to both sides of the equation to get x equals positive 6. However, go back to the restriction. We end up with x is not equal to 0 and 6. Those are exactly the same 2 solutions we came up with, and neither of those is allowed because of the restriction. So we have no solution for this equation. Our last example is number 6, and we have x divided by x plus 4 is equal to 2 divided by x plus 2 minus 2x divided by x squared plus 6x plus 8. So we can see that these first 2 denominators are already completely factored, but we have a trinomial here in this last denominator, so we'll need to do some factoring here. We may be able to use one of the other factors as a clue with our factoring in this trinomial. We know that x squared must come from x times x, and our product is 8. So either 1 times 8 or 2 times 4 would make 8. Looking at these options, we need a sum of positive 6. Is there any way that 1 combined with 8 would make 6? Not with addition or subtraction, so I'd eliminate that option. And then 2 and 4. Well, positive 2 and positive 4 would make positive 6. So probably our factors are going to be x plus 2 and x plus 4, because that way we'd have the right product and sum. To create our lowest common denominator, we're looking back at each denominator for unique factors. So x plus 4 would be one factor. X plus 2 is another unique factor, so we'll include the quantity of x plus 2. Our last denominator factored into those same factors, so it looks like we have our lowest common denominator coming from the factor of x plus 4 times factor x plus 2. To find the restrictions, we're going to set each of these factors equal to 0. So we'll start with x plus 4 set to 0, and that means when 4 is subtracted, we would get negative 4 for a restriction. The other factor of x plus 2 set to 0, subtracting 2 from each side, we would get a negative 2 as our other restriction. So the domain would be the set of x such that x is a real number, but x cannot equal negative 4 or negative 2. So now we'll use the lowest common denominator and multiply every term in the equation, starting with x plus 4 times x plus 2. Our first term is x divided by x plus 4. That will be equal to our lowest common denominator multiplied by our next term, 2 over x plus 2. And since we have subtraction, I'm going to use that bracket to ensure I remember to distribute that negative. Starting with the lowest common denominator again, I'll multiply by our final term, which is 2x for the numerator, and I will keep the denominator in its factored form. So we should be able to have some reducing and elimination of fractions. The quantity of x plus 4 is eliminated. In the next term, the quantity of x plus 2 eliminates, and in the bracket we have both quantities eliminating. We have x now to distribute to each term in this quantity. That leaves us x squared plus 2x is now equal. 2 is being distributed to each term in this quantity, so that would leave us 2x plus 8. Now let's work inside the bracket first. It looks like the only term here is 2x, so the negative will distribute to that 2x, making it minus 2x. When I scan the equation, I can see that it is quadratic, so most likely we'll need to use some factoring to finish solving. To collect like terms, I have x squared plus 2x on the left, and on the right-hand side you'll notice that 2x and minus 2x eliminate, so x squared plus 2x equals 8. I'll need to subtract 8 from each side so that I can get this quadratic equation in its standard form and equal to 0. X squared plus 2x minus 8 is equal to 0. So factoring is going to be needed here. X squared comes from x times x, and our factors of 8 will either be 1 and 8 or 2 and 4. To get a positive 2 for the middle, 1 and 8 are not going to have a way to ever make positive 2. So it looks like 1 and 8 are not an option. Let's try the other factors, 2 and 4. Somehow we need a product of negative 8. That tells me that either 2 is going to be negative or 4 is negative. But since the sum has to be positive, that means the larger value needs to be positive and the smaller is the negative. So how this works is we're combining minus 2x with positive 4x, and that will make our positive 2x in the middle. And just checking the last term, negative 2 times 4 will make our negative 8 for the product. Using our zero factor property, set each factor equal to 0. Our first factor is x minus 2, so when I solve that, I'm going to end up with x equals positive 2. Our other factor is x plus 4 set to 0. When I subtract 4, I'll get x equals negative 4. Checking back with our restriction, I can see that x cannot equal negative 4. So I will need to eliminate that option. X cannot equal negative 2. Well, this is a positive, so we'll get to keep x equals 2 for a solution. Now remember, with these restrictions, the whole reason we have these restrictions to consider is because these are the values of x that would make at least one of these denominators 0 and therefore undefined.